In the area of, this is a trapezoid right here, I can tell because it has one pair of parallel sides. So we're going to find the area. The formula for trapezoid is 1/2 the height times the sum of the bases, or you can write it as the height times the sum of the bases divided by 2 is the formula. And in this particular trapezoid, we can see that the top base is 6, so that's like base 1. The bottom base would be the sum of 6 and 18, so that would be 24 for the bottom base. And then to find the height, we don't know the height, so we need to use this right triangle that's on the left side here. We have the hypotenuse of the triangle, and we have the base of the triangle, and we're needing to find this other side of it. So we'll have to use Pythagorean theorem. So 6 squared plus x squared would equal to 10 squared. So using the Pythagorean theorem here, we will get 36 for 6 squared and 100 for 10 squared. Subtract 36 from 100 and we'll get 64. And then you need to square root that to get x by itself. So x alone would be 8. So the height of this trapezoid is 8. So now we have all the information to fill in for the area formula. So we have the height of 8, base 1 is 6, plus base 2 is 24, and then all of that needs to be divided by 2. So this is really 8 times 30 divided by 2, which ends up being 120. This doesn't have any inches or units like that, so we'll just leave it at 120. And that's that one. Let me move this up a little bit. The next problem I want us to look at is to find the area of this figure. This figure right here, since it has 4 congruent sides and it kind of makes this diamond shape, this is called a rhombus. And the area formula for a rhombus is diagonal 1 times diagonal 2 divided by 2. And you need the entire length of the diagonal. So in this picture, one thing that's true about rhombuses is that the diagonals, they bisect each other. So this bottom piece being 3, we also will know that the top part of that is 3. So that diagonal that's going up and down is a total length of 6. And then the other one is 8 across, and so the right side of that is also 8. So that one is a total of 16 across. So now we've got our 2 diagonals for the area formula that we need, and so we'll fill them in. Diagonal 1 would be 6, diagonal 2 16, so 6 times 16 divided by 2 is going to be 48 for the area of the rhombus. And the third one I want us to look at for this video is a kite. Here is our kite. In this kite, we've got 2 pieces of this horizontal diagonal, and the kite formula is the same as the rhombus, diagonal 1 times diagonal 2 divided by 2. So this diagonal going horizontally across is 24 plus 15, so that diagonal is 39 in length. And we need to figure out the other one. The other one doesn't have anything labeled on it, so I'm going to label this with like an X here. In a kite, the diagonals are perpendicular to each other, so we can use Pythagorean theorem here to figure out this piece of the diagonal. So to use that Pythagorean theorem, it would be 24 squared plus x squared equals 25 squared. And so when we do 25 squared minus 24 squared and square root that, we'll find that x would be a length of 7. That means this top part is 7, and in a kite, the diagonal that you see going horizontal, it's not bisected. But the other one that's going up and down here, they are equal lengths here because the horizontal one sort of splits it into two triangles that are the same. So this is 7 on the top and 7 on the bottom. So this diagonal here for this kite is 14 in length. So now I've got my two diagonals, so I can fill them into the area formula. Diagonal 1 is 14 times diagonal 2 is 39 divided by 2. So 14 times 39 divided by 2 is 273 for the area of this kite.